Live right now. Okay, so it is 12:17. Okay, so our objective today really is to talk about radians, conversion between radians and degrees. Okay, so for us, when I talk about radians, okay, gotta stop talking. When I talk about radians, it's an angle. Okay, one more time. When we talk about radians, it is an angle. Radians are angles. Radians are angles. What is a radian? It is an angle. Okay, which is weird because if you look at the circle, and we're going to create the circle, you see all those pi thingies? Those are angles, but they're angles that relate the arc length to the angle. Now, 1 radian. Here's the definition of 1 radian. If in a circle you have a radius of 1 on both sides, and you can take that circle, think about it, okay? Watch my hand, okay? Are you watching? Okay, my hand opens up, okay, and the angle gets bigger, at what point do you say, stop, Mr. Davies, where see the invisible? Yeah, there's an invisible arc right here. Okay, as I'm opening it up, okay, at what point do you say that the length of my hand is equal to the invisible? Right about there. Guys, you see it? So as I open up my hand, at what point do you say, okay, the invisible arc is equal to my hand length? Maybe right about there? A little less? So where it happens to happen, where the radius and the opening arc length are all equal to 1, that defines a radian. 1 radian, so 1 radian is where the arc length is equal to 1 inch, 1 foot, and the radius is 1. So 1 radian is equal to the arc length of 1 with a radius of 1. So the circle's got to have a radius 1. So in this case, that defines a radian. So the cool part is that you have an angle with the exact same size as the arc length, okay? Now if we go to this darn circle thing, you're going to see these pi's. You're going to see pi halves, pi, and these are the same thing. So if 1 radian is right about here, okay, then check this out. This is 1 radian. Then if I go halfway around the circle, this is 3.14. Half a circle, the length is going to be pi, which is arc length of pi, angle of pi, okay? So, standard position. So any angle that's less than 360 degrees is going to be in standard position, okay? Now, example 1. Draw a picture and give the angle in standard position, okay? So if I've got a 400 degree angle, all right, let's check it out. So I'm going to go around the circle. Now this is degrees, right? I know it's degrees, so 360. This is not bad. So if I want to go 400 degrees, think about your car tire. You've got your car, and you're going to roll your tire. Your tire's going to go 360 plus what? For 400, 360 plus 40 more. There's my angle. So I went all the way around 360 degrees, and like Isaac said, 40 more. So a 400 degree angle is like rolling your tire all the way forward on your car and a little bit more, right? Okay, negative 100 degrees. So it's still in degrees. So negative 100 degrees is rolling your tire backwards. Does that make sense? So I'm backing up my tire, and I'm just going to roll it backwards. So here's my circle. I'm going to, instead of rolling it forward 100 degrees, I'm going to roll it backwards 100 degrees. Does that make sense? So I'm in my car. Yeah, hey, Mr. Davies, I think I've got a I've got a screw in my tire. I'll say, back up your tire 100 degrees, and I can check it out. So you take your tire and you back it up 100 degrees, which is right about there. That'd be negative 100 degrees, okay? And then I can look at your tire and say, yeah, sure enough, you got a screw in the tire, you better take it in and have it fixed, right? So you back up your tire so I can see it, okay? Now, C is a little bit more difficult, but what we want to do is this, okay? This is in radians. So, in radians, from here to here is pi. From here to here, all the way around is 2 pi. And it comes from the circumference of a circle, okay? So if I've got 15 fourths, let's see, 4 goes into 15 how many times? 4 goes into 15 how many times? 3 times, right? Remainder of 3, right? So 15 fourths is the same as 3 and 3/4. You okay with that? 15 fourths, same as 4 divides into 15, 3 times. Now, let's see if we can figure this out. So if this is pi, then right up here on top is half of that, or pi halves, okay? So think about this. If that's pi, then that's half the journey, or pi halves. And then right here is a fourth of the journey, or pi fourths, okay? So really, every 45 degrees, and how many of those do I need? I need 3 and 3/4 pi. Let's see if we can do that. So you ready? Watch. Everybody watching? 1 pi. I'll do it again. Watch. 1 pi. 2 pi. 3 pi. And I got to go then 3/4. So I got 1/4, 2/4, 3/4 puts me right here. I'll do it again. Okay. 3 and 3/4. There's 1 pi, 2 pi, 3 pi. And then I need 3/4 of it. 1/4, 2/4, 3/4. The angle I want is right there. So we're going to spin 1 pi, 2 pi, 3 pi, and 3/4 puts me right there. All right. Back to degrees. So back to degrees. So I've got a 60-degree angle. So let's check that out. So if I draw a 60-degree angle in here, it's right about there. Okay, that's about 60 degrees. So now find an angle both positive and negative. So I'm looking for 2 new angles. I want 2 because I want positive and negative. That is coterminal. So coterminal is this, in the same spot. So you're in your car. Here's where your tire is. And I say, okay, Lily, spin your tire forward. So if you spin your tire forward, Lily's going to spin her tire all the way around to the same spot, right? Now your tire's moved, right? But we're in the same spot. So how many degrees are you at now? Well, you got the 360. You got the 60 plus the 360. Okay, so I've got my 60 degrees. And then we also rolled it another 360. What's that? Should be 420, right? So 420 degrees and 360 are the same spot. Same spot, right? I'm here, or you roll your tire full rotation, and so 60 plus your 360 is 420. Same spot, right? Now, what if I roll it backwards? Roll it backwards, right? I want to roll it backwards and bring it to the same spot, right? So it's just your 60, and I subtract 360, right? Does that make sense? So what's that? Negative 300. So all 3 of these angles are in the same position. One's just rotation forward 360, another's rotation backwards 360. Does that seem pretty easy? Okay. Okay. B. We'll do the same thing, except for we have to start with a negative 120 degrees, okay? So we already have a negative angle, right? So negative 120. Okay, you ready? 90, 120 is right about here. This is about a negative 120 degrees, okay? Negative 90, 30 more, right? Okay, now, let's roll this thing forward. Okay, I want a positive angle, so let's roll it all the way forward. How do we get it to roll all the way forward? We got to go a full circle. How many degrees is in a full circle?
360.
Good. So let's take our negative 120, and we'll add 360 degrees. Okay.
It's 240.
So it's positive 240. Same exact spot, but one's rolling the tire forward, and one's rolling it back. Okay. Now Isaac says, "Well, Miss Davies, I want to roll my tire back a little bit more so you can see my tire better." So then if Isaac wants to roll his tire back another 360, if Isaac says, okay, I want to go back another 360, we'd be going backwards, wouldn't we? So another angle for this one would be my negative 120, and I'd subtract another 360 to roll it backwards again, right? So then what's that? 480. So that's a negative 480, right? Okay, let me circle that, and circle that. So in B, I've got three angles that are in the exact same spot, right? I've got a negative 120 degree angle, or I roll my tire forward and I get a 240 degree angle, or I roll my tire back again and I get a negative 480. They're all three in the same spot.
Negative 480.
Yeah, negative 480. Yeah, thank you.
I said 480.
Yeah. So they're all three in the same spot. You guys agree? One's just rolling the tire forward, rolling it back, and rolling it back again. Okay, now, with pies, it gets a little tricky. So let's first of all do this. I'm going to draw a picture. So, 2 pi thirds, okay? So, 1 pi third is here because it's a third of my pi. My other 2 pi thirds is here. We're going to learn this because we're going to create the unit circle, but this is just an introduction. So we have a circle. We roll our tire's sitting right here, okay? All right, let's roll it all the way back around. Okay, so we're going to rotate our tire full revolution forward. Now, yeah, 360 degrees, but with this, with pies, if we go around a circle, we're going to add 2 pi. One full circle is always 2 pi in radians, okay? So we're going to add 2 pi. So we get 2 2/3 pi, believe it or not, is our rotation. So we get an answer of 2 2/3 pi, okay? Every time we go around a full circle, it's 2 pi. I'll say it again. When we go around a full circle, it's 2 pi, okay? Now, if I go backwards, and I want to go the other direction, if I want to go from here, and I'll get all the way back to the same spot, I'm going to take my 2 pi, and I'm going to subtract. Okay, again, one full circle is 2 pi. So I'm going to subtract 2 pi. Okay, 2 pi minus 2/3 pi. Okay, I'm going to get a common denominator. It's going to help. Okay, 2 pi thirds minus 6 pi thirds. Okay, don't let this confuse you. 6 over 3 is 2, right? Don't let this confuse you. Guys agree 6 over 3 is 2? And I did this because I got fractions. And then 2 minus 6 is 4. So I get a negative 4 pi thirds. Okay, now, these radians are all new to you. But by the time I get done, a week of this, you're going to get it, okay? So, these three angles are all the same spot, okay? All right, ready to turn the page?
Oh God.
Okay. All right, now, draw the reference angle. So what is a reference angle? So a reference angle is an angle, okay, a reference angle is an angle less than 90 degrees on the x-axis, okay? Write that down, okay? A reference angle is an angle less than 90 degrees on the x-axis, okay? Well, let's see how that works, okay? So I'm going to look at this. I'm going to draw A. Okay. 160 degrees, I think, is like right, it's right here, isn't it? 160 degrees? Because I know that's 180, right? So 160 degrees is there, okay? Now, the reason we do reference angles is because we really want to do right triangle trigger this stuff. And 160 degrees won't make a right triangle, right? So I need, okay, and I'm going to highlight it so you guys can see it. What I really need is, I have a highlighter. I got a pen. What I really want is this triangle here. You guys see this triangle here? That's my right triangle, okay? So if that's my right triangle, what's the angle right there? That's the theta I'm looking for. It's 20 degrees. You guys agree? That's your reference angle. It's actually that easy. So you want to find the angle less than 90 on the x-axis. My reference angle is that angle there, which is 20. Okay. Now, 340. Let's check out 340. Okay. So I know if I go all the way around the circle, it's 360, right? So 340's got to be right about there, right? So 340 degrees is, yes, 20 again, isn't it? You guys agree? It's 20 again. Do you guys agree with okay, yeah, it's got to be 20. You guys agree? Theta is 20 degrees. So my reference angle, theta, is 20 degrees. It's easy. You guys agree? So the reference angle is just making that angle less than 90. Okay, and then 5 pi 6. Now, 5 pi 6 is a little bit different, and we're going to make the unit circle so you guys will start to get the hang of it. But 5 pi 6 is right here. And we're going to learn this very soon about. So 5 pi 6 is here. And this is pi. Okay? So I want this angle here. Okay, so let me back up over here. So how did Caden get the 20? How did Caden get the 20? I mean, just tell me. It's so obvious. How did he get the 20? 180 minus 160, right? So we're going to do the same thing here. We're going to take pi, because here's my theta, pi minus 5 pi 6, okay? Yeah, so you okay with 6, 6? 6, 6? Why would I want to make 6, 6?
Common denominator.
Yeah, common denominator, okay? Because that's just 1 pi 6, 6. If I subtract, I get a 1 pi 6. And that's my reference angle, is 1 pi 6, okay? Now, if radians really are the same thing as angles, right? And they're all over this circle, right? You guys see 45 degrees, and you can see pi fourths. 6 degrees, you can see the pi thirds. I don't know if you can see it because it's dark in here, right? But these are all angles. They're the same angles. So these 9 degrees, pi halves, they're the same angles. But, so 100 degrees is an angle, right? We know that. And we want to convert 100 degrees into radians, okay? So here's our formula. It's this easy. So our formula says, okay, I want to go radians are equal to, well, I'm going to put in my formula, watch, put my 100 right there, because that's my theta. So I put my 100 right there. I'm going to go 100 over 180 pi. So I'm just going to put my angle there. That's theta, right? And that's the answer, but we can reduce this. So if you can reduce this, I will. I'm going to reduce it, and this will reduce to 10/18 or 5/9. So 5 pi 9 is the exact same angle as 100. They're the same angle, but one's in degrees and one's in radians, okay? Same thing, negative 300 degrees. We put my negative 300 into here. So my radian is equal to my negative 300 over 180 pi. So just put my number into there. And that'll reduce too, right? That'll reduce to 30/18, or if I divide both those by 2, I'll get, let's see, divide them by more than that. Let's see. I can divide by 30/18, I can divide by 6, right? And I get 5/9. I get all the way down. Now, if you're not sure how to reduce, how many kids cannot reduce fractions? Check it out. Your calculator will do it for you. Check it out. If you go to, it's in math. You got to go to math, and if you go negative 300 divided by 180, okay, I want to reduce that fraction. Go to math, fraction, boom. Does it for me. Negative 5/9. Negative 5/3. Oh, glad I double checked. Negative 5/3. So my radian is negative 5 pi thirds. Okay? Now, if we can do the same thing, if we can take a radian, which is an angle. But what is it? 5 pi 6, what is that angle? It means nothing to you now, but if we can change it to degree, it should make something. So we get, so we take the same angle, we put it into this formula. So we take our 5 pi 6 and put it in for the r, for the radian, and say, okay, degree is equal, yeah, you're totally right, 180 over pi times my 5 pi 6, okay? So I just plug this into my formula, okay? Now, if I take a look at this, do you see anything? I want to simplify. Do you guys see anything to simplify? Hopefully you do.
Pi.
Yeah, pi. What about the pi? You're totally right.
You get rid of
You get rid of them, right? I totally agree. Yeah, get rid of the pi. So pi's cancel pi's. You guys agree with that with Isaac? So in my calculator, I'm going to go 180 times 5 divided by 6. I'm going to go 180 times 5 divided by 6. My calculator, I'll get what degree this happens to be. So 180 times 5 divided by 6. I get an answer of 150 degrees. And you saw that on the unit circle, didn't you?
Yeah.
Yeah. Okay, now 1. 1 radian is about 57 degrees. How do I know that? 1 radian is about 57 degrees. How do I know that? Well, let's use our formula, okay? So if I plug in my 1, my degree is equal to 180 over pi times my 1, okay? So I'm going to use my calculator, 180 divided by pi times 1. Well, I don't really need times 1. And again, it's about 57.3 degrees. Okay, so really back to the hand thing, okay? Back to the hand thing, okay? Watch. Invisible arc. When do you think the length of my hand and the invisible arc are about the same thing? You right about there? Right there? That angle's about 57.3 degrees. It'll always be 57.3 degrees, where the hands are the same length as the invisible arc, okay? And that's what radians do, okay? Now, last but not least, so we've got a formula. If you want to find the arc length of a circle, you get this formula. S is the arc length, okay? And it's a great formula. The only problem is theta isn't going to be 50 degrees because the degrees don't relate to the arc. I'll say it again. We saw that. The degrees do not relate to the arc. But in radians, they do. So first of all, before we can do anything, we've got to change my 50. So theta is going to equal 50 over 180 times pi. Where did I get that? I got that up here, right? We're going to convert our degree into radians. We got it? Our angle must be in radians. So the first thing I do is I change my angle into radians, okay? And I'm actually going to use a decimal because I need a length, right? I'm going to change that. I'm just going to use a decimal. So 50 divided by 180 times my pi. I get an answer of about 0.87. So my angle, weird, huh? This is my angle, 0.87. Doesn't even seem like an angle, 0.87. Well, that's an angle. That really is an angle. It's an angle in radians. So if I want to find the arc length, I can do this formula here. S is the symbol for arc length. It's just S equals my radius, well, 8, times my 0.87, and I get an answer. Yeah. And I get an answer about 6.98 or about 7 centimeters. This is pretty handy stuff. Handy because I'll give you a real practical application in my world. Okay, shot and disc. Okay, shot and disc, right? If we need to know the length of that toe board, right? That's just one application. Right? Okay, then area, if I want the area of this, okay, again, we've got a formula. K is the symbol for area, and K is equal to 1/2 r squared times theta. But theta is not 50 degrees. It's not 50. The theta is in radians. Well, luckily, I already know what that is. I already changed the angle. So I'm going to go 1/2 8 squared times 8 squared times my 0.87, and that's going to give me the area of that sector. So 0.5 times 8 squared times 0.87, and I get an answer of about 27.84. 27.84, and that's in terms of centimeters squared because it's an area. Okay, so a lot today to digest. Okay.